we have our slope-intercept form, which is y equals mx plus b. We're going to talk through another form of a line, which is called point-slope form. That's why it's type point-slope form. So we're just going to practice today writing point-slope form. And then kind of our last example today, I'm going to show you how you can go in between. You could start a point-slope form and then get to our slope-intercept form. So first point-slope form is, we're going to, in that first blank, it'll be our, what it'll look like. It is, where's my line? It's y, you say minus y with the little 1, so we say y1. And that's equal to, and we go, it's m, then x minus x1. It's a little bit longer than slope-intercept form, but it functions essentially the same. M is still going to be our slope value, so we'd say m is equal to our slope. And x1 comma y1, so this x1 and y1 that is in our form of a line. That is just going to be a point that we're given. So we're going to be given a point, we're going to plug it in, and we're going to plug our slope in, and we're going to simplify it nicely. So this part you don't have to write down, but how we get this is, we know that our equation for a slope, so again, you don't have to write this part down, I'm just saying that, because sometimes people think that like math formulas just drop from the sky, and no, they're like, how does this actually happen? Well, if we put this m divided by 1, we could do what's called cross multiplication. Multiply here and here together, and here together. And that's the same thing as y2 minus y1 is equal to m. And then cross multiply, we multiply m times all of this. x2 minus x1. And then we only need 1 point, so we drop off the 2's. This is what's called like a derivation of a formula. It's kind of just saying where it's coming from. That's not something you're going to be tested on or anything. It's just kind of good to know. Well, let's put this into practice. Example 1 says, write an equation of a line in point-slope form where your slope, or your m, is equal to 2, and your line passes through the point 9, comma, negative 2. So I'm going to do a few things to start like I always do. I'm going to label what I have. I know my m value is going to be 2. I have a point, and that point I'm going to use for my x1 and my y1 value. So I'm going to label it x1, y1, and that's really all I need to begin my problem, just knowing what my two pieces of information that I'm given. I'm going to write out the form again, just so it's right near the problem so we can see what we're doing. Y minus y1 equals m, x minus x1. And just like we were doing on Monday and Tuesday, this is just knowing what information you're given and knowing where to plug it in. We're going to plug in a 9 for x of 1 and a negative 2 for y of 1. So again, I'm going to do those when I'm plugging those two numbers in. Actually, I have to plug in my slope too. So I'll do all the numbers I'm plugging in. I'll do my points in blue, and I'll do my slope in red like I have been doing. So we'll do it y minus our y1 value. So we said that was -2, so I'm going to write -2 or -2 is equal to our slope. It told us was +2. So I'm plugging a +2 in for m. Then I'm taking x minus whatever my x1 was, and we labeled that as that was 9. So we're writing we're going to see what we can clean up. Most of the time, when I say clean up, if we're just writing something in point slope form, it's changing any subtracting a negative into a chunky plus. So that's all we have to do here to simplify. We're going to change this into a chunky plus. So we'd say y plus 2 is equal to 2x minus 9. And that's how you write something in point slope form. Right now, that may not look like a whole bunch to you, but when you get to your last problem, you see how this can flip into slope-intercept form. We could still graph this if we wanted to, because we have a point, +9, -2, and we have a slope of 2. So we know where we could start from and how many to go up and over. Let's try another example. Again, we're just practicing plugging in things in the correct spaces. So this time we have a slope of 5, our m is equal to 5. And our x1 and y1, we have 1. And our y1, there we go. So again, I'm just going to write this out so we can see where our pieces are going. So y minus our y1 is -9. So I'm going to do minus, again, this will be a -9, equal to our slope we said was 5. So a 5 goes in for m. Then x minus whichever our x1 is, and that's 2. I could write +2, but writing minus plus is just the same thing as minus, so we just plug in 2. Again, all we have to do to clean this up is change that subtracting a negative to a chunky plus. So y plus 9 is equal to 5, x minus 2. Point slope form.
So, this one has.
Yep. All right. Give number 3 a shot, example 3 a shot on your own. Hopefully now you've seen 2 examples. You can kind of understand where pieces go. So the only way Now jump them into it together. What's different now is our x value is negative. So we have a negative 7. Our y value is positive. So we do, it'll be y minus 4 here equal to, we have a slope of 4. And we have x minus, but here now we would have a negative 7. So now we're going to have a chunky plus inside the parentheses instead of next to our y. So you're right, y minus 4 is equal to 4x plus 7. Just that's changing. And this next example, example 4, is kind of just looking ahead to what we'll do on Monday. All right. Today we're just focusing on, can you plug in things where they're supposed to go and write it out correctly? On Monday we'll say, okay, let's write it in point slope form first. Well, writing this in point slope form, I'm given my point, I'm given my slope. So it would be, let's say it would be y minus 11 is equal to 9 over 2, x minus 2. Again, this is my x1 and my y1. This is my m. That's in point slope form. I can take this and do some simplifying and change it into y equals mx plus b by doing two things. First, distributing. So distributing just meaning multiplying into my parentheses. So I multiply this 9 over 2 to here and here. I would get y minus 11 is equal to 9 over 2x, because 9 over 2 times x, because there's a 1 in front of here, 9 over 2x. 9 over 2 times negative 2 would be, would that be negative 9? So that's after one step, just distributing. Well, we need y equals mx plus b, so we want those y by itself, so you'd have to add 11 to both sides. We have to add this 11 with the 9, because those are its like terms. So we add 11 to both sides. We say now y is equal to 9 over 2x plus 2. And there's slope-intercept form and point-slope form. All right. Same line, they just look different. Here we have our slope and our y-intercept, positive 2. Here we have our slope and just any 2 points you can plug in. All right. So kind of going back to Shane's question, what do you need to know for a test or something? You need to know, we're going to start off, you need to know how to do this, just what point slope form is and where to plug things in. And you'll also have to get to the point where you're comfortable taking this point slope form and switching it into slope intercept form. So just by distributing and adding your number that's with your y over to the other side. So on the back side, the part that you will do